The last thing that we do is that we're encouraging student collaboration. What we know from our research and from actually all research on kids with learning is that they like to work together. And computing can be inherently collaborative. Our research shows that when we study collaboration, we can see how are kids asking for help. Are they being adaptive? Are they able to ask for help in a constructive way? Are they collaboratively problem solving, or are they asking somebody to do the work for them because of learned helplessness? And are they sharing excitement and pride in their work as well? The other thing we see is that we really need to teach children how to collaborate in order to make that the most effective it can be. One of the things that we've done is teach them a collaborative discussion framework. This was created by a couple of teachers in Unit 4, in Champaign Unit 4 School District. And so we've taught the students to say things like, "What are you trying to do?" rather than actually have the kids do the work for each other, and then ask, "What have you tried already?" Or "What would happen if you would do X, Y, or Z?" And what we've seen is that when we teach kids to use this kind of collaborative discussion framework, they end up working together much better than if we just kind of let them loose. Otherwise, they'll just ask their friends to do the work for them, or they'll ask a teacher to do the work for them. When we teach them to collaborate in this way, we see increased persistence, we see much better adaptive help-seeking behaviors, and we see much better collaboration. And the way that we study this is we've created a tool called the Collaborative Computing Observation Instrument. So what we do is we use screen capture to look at what the student's doing on the screen, and we listen to their conversation so that as they're computing and they're working both individually or with their friends, we're able to see, are they using the strategies that we're teaching them? And so here are some things that we found from that. Students might spend a lot of time persisting and not at all finding success if they are not taught specific strategies to help them forward. They might spend an entire class period trying to figure out their code, but be very non-strategic about it. So as they see that their code is broken, they might completely break it apart and then put it back together and completely break it apart. And they could spend an entire afternoon doing that, still be engaged, still look like they're learning, but not actually get anywhere. For these kids, what we've seen is that collaboration disrupts their flow. They're like playing it like a game and they don't want to stop. We also see that sometimes even when kids are encouraged to collaborate, they may not find success. In fact, in most of the instances in our research that we've had kids collaborating, they weren't able to solve the problems on their own, even with this script. So the next step is to provide them with some tools to help along the way. One of the big things we teach in computing is something called debugging. So when my code is broken, there's a way for me to come up with why my code isn't working. And so we're teaching kids to really reflect on things like, what happened when I ran my code? What did I expect my code to do that it didn't do? Is there any part of my code that's actually working so that the students don't break apart their entire code? And where is it that can they actually isolate where the problem is? And if they can do that, then they can use a collaboration strategy to actually be able to go to their friend and say, you know, I've tried to do this and it didn't work. Can you help me with this particular part of my code? So then using these questions, the students are able to work with their friends and collaborate in a much more productive way.